Welcome to Algebra, finding slope from a table. In the last lesson, we learned how to find slope by looking at a graph and counting the steps for the rise and for the run to find the slope. Another way to represent linear data is by using a table. In this lesson, you'll learn how to find the slope of a line represented by linear data in a table. Finding slope from a table is very similar to using a graph, finding the change in y, the rise, over the change in x, the run. When using a table or a graph, it doesn't matter which 2 points are selected. If the data in a table is indeed linear, the calculated slope will be the same between any 2 points. Always check more than one pair of points to make sure all changes are the same, confirming the data is linear. First, find the changes on both x and y columns of the table. Here you see the x changes by 2 each time and the y by 6 each time. The slope is the change in y, or f of x, over the change in x. And in this case, m, the slope, is 6 over 2, which is 3. Using a table is an easy way to see that the slope is the same, confirming the data is linear. Be careful to ensure the table data coordinates are in proper sequence. Does this table contain linear data? We check the changes and see that the changes for x are the same, plus 2 each time, but the changes for y are not, plus 6, plus 3, and then plus 5. The slope for the line passing through the first 2 points is 3, 6 over 2, and we see this on the graph, which does not contain the other 2 points. The middle 2 points are on a different line with a different slope, 3 over 2, which does not contain the first and last points from the table. The last 2 points are on a different line than the other 2 points, with a slope of 5 over 2, which doesn't contain them either. Clearly, the data in this table does not represent a line. It is not linear. Is the data in this table linear? If so, what is the slope of the line the data represents? We find the changes in f of x, or y, and the changes in x, and see that they are all different. Plus 4, plus 6, plus 12 for the y column, plus 2, plus 3, and plus 6 for the x column. However, checking the slope between each pair of points shows the same result. 4 over 2 is 2. 6 over 3 is 2. 12 over 6 is 2. The resulting graph shows all points are indeed on the same line, proving the data in the table is linear, and the slope of this line is 2. Here are several tables for practice in finding slope. In this first one, we can see the changes are the same for both columns, resulting in the points shown on the graph with a line that has a slope of 3. To show how to do this in Desmos, let's go through the process step by step. First, we add a table, which shows 2 columns, x1 and y1. We enter the 4 points, 1, -1, 3, 5, 5, 11, and 7, 17. We click each point on the graph, and the label shows up. It looks like the points are all on the same line, but there's a way in Desmos to show the line that contains all the points in this table. In Desmos, below the table, we enter a magic formula. y1 is approximately equal to mx1 plus b. The symbol for approximately equal to is on the top left key of the keyboard, right next to the 1 key, and you use the shift key to generate this symbol. This is the slope-intercept form, y equals mx plus b, and you can see it automatically generates a line going through the points on the table, which visually proves that the data in the table is indeed linear, and all the points are on the same line. Let's continue with the next exercise. Here we can see the changes -1, -1, -2 for y, plus 2, and plus 4 for x, and we can see that they are indeed all on the same line with the slope of m equals -1 over 2. For this example, stop the video, work it out yourself, and then start it again to see how you did. In this case, the changes for x are plus 1 each time, but the changes of y are +3, +5, and +7. And we can see the points are not all on the same line. There's a line there on the graph that tries to fit them all, but it's not exact. And so this set of points is not linear. This table does not contain linear data. Try this one now. In this one, we have +3, +6, and +9 on the x side, -2, -4, and -6 on the y side. You can see the resulting points on the graph, and the line that fits them, the slope is -2/3. Try this one. Here, the changes in x are +2 each time. The changes in y are -4 each time. You can see that the points are on the graph, they all form a straight line, and the slope is -2. Try this one. Here, the changes in x are +10, +5, and +5. The changes in y, or f of x, are +4, +2, and +2. They are all on the same line, as you can see from the graph, and the slope is 2/5. In this one, the changes in x are +0 each time. The changes in y are +4, +2, and +3. We see the points on the graph, and it looks like a straight up and down line, a vertical line. And indeed, it is. And if you remember from an earlier lesson, this means the slope is undefined. Try this one. The changes in x are +2 each time. The changes in y are different, +5, +1, and +8. You can see the points on the graph don't line up, and the line that tries to line them up doesn't quite hit them all. And so this table does not contain linear data. Try this one. Here we can see the changes in x are +4, +6, and +8. The changes in y are +2 and +3 and +4. The points all line up, and the graph shows a line with a slope of 1/2. How about this one? The changes in x are +2, +3, and +4. The changes in y are +0 each time. You look at the points, and they're straight across. This is a zero slope line because it is totally horizontal. Try this one. Here, the changes in x are +3, +2, and +3. The changes in y are +3, +2, and +3. And you can see the points do line up. The graph does fit all 4 points, and the slope of this line is 1. And this last one. The changes in x are +5, +5, and +5. The changes in y, or f of x, are all -3. And so you can see the 4 points indeed line up, the line fits them all, and the slope is -3/5.